doing section 5.6, which is fitting a line to data. So first we need to know what a scatter plot is. It is a graph used to determine whether there is a relationship between paired data. So paired data given its points that we will be given. Okay, so there's going to be three different kinds of correlation that we're going to talk about. So this doesn't have to be this does not have to be specific points. I just want you to get the general gist of where this is going. So if we have data that looks something like that, and we can graph a line through it that has a positive slope, then this is called positive correlation. So similarly, if we have a bunch of data points that have a downward trend, then we can graph a line through it with a negative slope, then this is called negative correlation. And similarly, if we have data points that really have no organization at all, that is no correlation because we can't really draw a line through that anywhere. So, we're going to graph some, I'm going to have two graphs down here. We have to figure out what kind of correlation they are. So, first one is going to be a graph about the hours spent studying versus test scores. And again, these don't have to be perfect. It's just going to be the general trend that we're looking at. So obviously this graph is going to have positive correlation. Okay, our second graph is going to have almost the exact same values on the side, and it is going to be the same, different labels. This one is going to be hours watching TV. And the same thing up the side. Test scores. Okay, and it's going to be the opposite direction. So if I had to say what the correlation of this was, I would say that it would have to be a negative correlation. Okay, so now we're going to make a scatter plot with given data points. So not just like the last one where we were kind of just getting the general trend. This time we're actually going to be graphing the points. So this is a chart that gives us lengths of fish versus their speed swimming. So we have to first make our scales down the side and bottom. Bottom is going to be the length of the fish in centimeters. I say we should go by tens. And up the side is going to be our speed of the fish in centimeters per second. Go by 50s in this general direction. Okay, so now I'm going to plot all these points. The first one is 37.8148. It's going to be about right here. Again, this is all just kind of guessing where these points are. Next one is 19.247. Third one is 21.388. fourth one is 26.2131. And the last one is 26.898. So if I had to graph a line through these points, what would my correlation be? What would the slope be? It would be positive. So positive correlation. And what this positive correlation means in our context is that the longer the fish is, they tend to swim faster. Okay. So the next thing we're going to do is make a line of fit. A line of fit is a line that fits most closely to the trend of data. So if I was to make a line of fit through this past example, I would probably put my line right about there. So the first thing that you need to do is make a scatter plot and then decide whether it can be modeled by a line. So if it's no correlation, obviously you can't make a line through it. And then draw a line that appears to fit the data closely. There should be approximately as many points above as below it. So if I look at the one I just did, approximately, that's pretty close. And then what you're going to do is write an equation using 2 points on the line. The points do not have to represent actual data points that we were given, but they must be on the line. So don't just draw the line through the points that you have. You want to draw a line that fits, and then afterwards you want to pick 2 points that are on it to make your equation. Not necessarily from the ones that were given. So we're not necessarily going to pick any of these points. We just want to pick points that are on the line. So first we need to make our scatter plot. This is years versus the number of active clusters of red-cockaded woodpecker clusters. So along the x-axis is going to be our time, and we're going to make our time years since 1990, so I don't have to write 1990, 1991, 1992 every time. So it's going to be 1, 2, 3, and so on. Okay. And up the side is going to be active clusters of woodpeckers. And I'm going to go by 5s. Okay, probably stop there. Now we need to graph all these points. So at 1992, we have 22 clusters. 93, there are 24. 94, there's 27. 27 again. 34. 40. 42. 45, and 51. Okay, so the next thing I need to do is draw a line through these points. Okay, I think that's a pretty good line. Now we need to pick 2 points that are on that line. They don't have to be points that we were given. So I'm actually going to choose the point 635 as one of my points. It's right on one of the corners. I'm going to put that one in green. That one's right here. And another point that I'm going to choose is 115. Again, neither of those were points that we were given, but they're both on the line that I drew. So you don't have to pick blue ones. You can just pick the ones that are on the line. Now I'm going to find the slope first. 35 minus 15 over 6 minus 1. That's 20 over 5, which is 4. And then I'm going to pick one of those 2 points, probably 115, to write my equation. 15 equals 4 times 1 plus b. 15 equals 4 plus b. B is 11. So our equation is 4x plus 11. So obviously if you drew your line a little bit differently, you will have chosen 2 different points and you would have a totally different equation. So all I'm going to be checking on your homework is the accuracy of your work. See, if you drew a line that was not in the middle, so it was not it was a poorly drawn line, then I'm obviously going to take points off, but if you did this correctly, you would get all the points. Okay, so from that equation, let's describe the domain and range. So let's just find those. Domain is the x values, and in this case, we start at 0, and our x values get bigger. And our range is our y values, and they start at 11 and only get bigger, so greater than or equal to 11. B, at about what rate did the number of active woodpecker clusters change? That would be the slope, and our slope is 4, so that's 4 clusters per year. And that's all we need to do on section 5.6 on scatterplots.